Two galaxy clusters pass through each other. Each contains galaxies and gas. The galaxies kept going. The gas collided, heated, and lagged behind. Then astronomers mapped the gravity. Its main concentrations had continued with the galaxies. The weight map was in the wrong place. Dark matter sent no usable light. The cyan lines are a calculation. Total mass, rebuilt from distorted background light. A map, not a photograph. Mira is our silent map maker. Her scene is schematic, her measurements real. She must map what no camera sees. First, what the unseen mass holds in orbit. Second, what it does to passing light. Third, where its weight goes in the collision. The crash comes last. To understand its strange map, we must learn how gravity drew it. Chapter 1. The spin. Count everything ordinary a spiral galaxy lets us measure. Stars, gas, and dust. Most of that inventory crowds toward the bright center. If nearly all the mass sat in the bright disk, the inward pull should weaken beyond it. Outer stars and gas should orbit more slowly.
How can one measured speed tell us how much mass is pulling?
A faster car needs more inward force to hold the same bend. A star has no road, but the rule survives. Speed and curve reveal the required pull. Gravity supplies the turn. A model of the galaxy's shape and measured contents must then reproduce that pull. Glowing gas emits sharp colors, spectral lines. Motion nudges them, the side turning toward us slightly bluer, the side turning away redder. Nobody waits hundreds of millions of years for one orbit. Vera Rubin, Kent Ford and colleagues measured those shifted lines in the faint outer gas of many spirals. The light thinned, but the speeds often stayed high. Flat rotation means the outer material keeps roughly similar linear speed. It does not mean equal orbital periods. Farther orbits are still much longer loops. Under standard gravity, the cleanest explanation adds a broad halo of unseen mass. It has no observed hard edge. Its fuzzy outline is inferred, not photographed. Add the final dust cloud. The balance still refuses. Dust has reached the limit of its abilities.
Could the rest simply be faint, ordinary matter that our telescopes failed to count?
Astronomers do find cold gas, dim stars, planets, and black holes. But the universe's oldest light independently records how much ordinary matter exists. That total is far too small. Dark matter supplies about 85% of matter, roughly 5 times the ordinary share. Dark matter pulls matter together. Dark energy is linked to accelerating expansion. Same gloomy adjective, entirely different job. Rotation is our first scale, a rough outline dependent on galaxy models and the gravity law. Some modified gravity ideas reproduce important galaxy patterns. Mira must also weigh clusters of galaxies, chaotic swarms with no tidy disk to read. Fortunately, background light crosses the scene for free. Chapter 2. The Bend. Place a distant galaxy behind a massive foreground cluster. Without the cluster, its light would arrive from one direction. With the cluster, several curved routes can reach us. A glass lens also redirects light, but the comparison stops there. A cluster has no glass. Its mass curves space-time, and light follows that geometry. One background galaxy can appear stretched into an arc, or appear several times around the cluster. It has not cloned itself. Gravity has simply been unhelpful with the formatting.
The picture is bent, but how does a bent picture become a weight?
First, measure distances to the cluster and the background galaxy. Then adjust a total mass model until its gravity reproduces the observed positions and shapes. Strong arcs mark the loudest distortions. Elsewhere, many ordinary-looking galaxies are stretched by tiny amounts. Their shared stretch reveals weak lensing. Those clues combine into a second scale, a projected total mass map. It can locate gravity even when the material causing it contributes no usable light. Those cyan contours are a calculation, not dark matter glowing. The color is ours. The input is distorted background light. Lensing measures every mass along the sight line, including stars, gas, and anything dark. Model the measured stars and gas, subtract their gravity from the total, and a residual remains, the inferred dark component. Rotation gave a rough outline. Lensing gives this residual a two-dimensional address. But the residual has no ingredient list. A model can separate contributions on paper. We need nature to pull the components apart in space. The opening collision can perform that test. Chapter 3. The crash. A galaxy cluster is not just its galaxies. Between them spreads thin, extremely hot plasma, glowing gas holding most of the cluster's observed ordinary matter. In the collision, stars from different galaxies almost never hit. The gaps are too large. Both galaxy populations continue through one another. The diffuse gas cannot do that. Charged particles meet charged particles, pressure builds, a shock forms, and the plasma slows. Heated this way, it glows in X-rays. The collision has now sorted the ingredients. Optical light locates the galaxies. X-rays locate most ordinary mass. Distorted background galaxies locate the total gravitational mass. This colliding pair has a name, the bullet cluster. Its dominant lensing mass sits displaced from the slowed X-ray gas, broadly following the galaxy concentrations. Most of the gravity is separated from most ordinary matter. That is why this collision matters. Changing gravity alone has a difficult job when the strongest gravitational effect appears away from the ordinary matter that would have to produce it. Researchers still test alternatives. Across galaxies, clusters, the early universe and cosmic structure, extra matter, not a change to gravity alone, remains the best combined explanation.
Does the bullet cluster prove which dark matter particle exists?
No. It constrains behavior. The dominant, unseen component mostly passed through this event, so it cannot behave like ordinary hot gas. That does not mean it never interacts with itself. Candidates include axions, hidden families of particles, primordial black holes, and heavy particles called WIMPs, or a mixture of several. Deep underground, a detector named LZ watched tons of liquid xenon, waiting for a WIMP to leave a flicker. None appeared. That empties part of one candidate's hiding space, not the gravitational evidence, not every possible WIMP. Mira's map can now record 4 honest lines: mass measured, location mapped, behavior constrained, identity unknown. So, how do you weigh something that emits no light? Measure the gravity required by its orbits. Map how that gravity bends passing light. Then watch where the mass goes when ordinary matter collides. Those tests measure how much unseen mass is present and where much of it sits. They do not tell us what the substance is or weigh one single particle of it. The opening collision is now readable. Hot gas remains near the middle. Galaxies continue outward. The projected total mass map and inferred dark residual remain broadly with the galaxies. The residual's identity is still missing. In June 2026, the Vera Rubin Observatory began its 10-year movie of the southern sky. Its images are designed to sharpen weak lensing mass maps across a much larger area. It still will not photograph dark matter. It will make the address more precise. Science can sometimes learn where something lives long before it learns its name.